Okay. Okay. So we have some confusion about the combustion. All right. So both of them have to do with octane. So formation of octane should be, so octane is C8H18. All right, so formation should be from the elements carbon and hydrogen, and then balance to form only octane. So it should look like this. That would be the formation reaction. Yeah. Combustion reaction of octane would be the reaction to combust octane. So you're going to do octane reacting with oxygen goes to carbon dioxide and water. And then we'd have to balance that. So what, 8 here? This would be a 9. Oh, I feel like I did this yesterday. 9 plus 16 is not a pretty number, so let's double this. Let's go 16, 18. So 32 and 18 together, so that'd be a 25, and this would be a 2. Okay, so that would be the combustion reaction for octane. And they would have, so does that answer questions about combustion? Anytime you write a combustion reaction, you should always have something reacting with oxygen. And the products are always carbon dioxide and water, unless they tell you it's an incomplete combustion. And in that case, you would also have carbon and carbon monoxide. Any questions on the combustion reaction? And they would have different enthalpies of reaction because they're very different compounds or very different reactions. Yeah. Okay, so on the problem that we were working on yesterday, we are going to do the chapter quiz on Monday. So Monday live. I think I have live Monday as, I don't remember anymore. Go check the week at a glance. I think live Monday is the quiz. And then asynchronous on Monday is your intro to chapter 17. I think that's how it works. So if you have questions over the weekend, make sure you ask them. Okay, so the the problem we were working on yesterday is this one. And they were asking us to compare standard enthalpy of combustion per gram of methanol versus gasoline. And we're assuming that gasoline's pure octane. Okay, so yesterday we left off here. And basically, we had used Hess's law to calculate the enthalpy that was released for the reaction. And since the reaction had 2 moles of methane, and this reaction was for 2 moles of octane, I just wrote that as a ratio in the end. So what we have to do from here is to get it, instead of being kilojoules per 2 moles of methane, we have to get it to be kilojoules per gram of methane. But before we do that step, does anyone have a question up until this point? We kind of did it fast yesterday and we didn't really have time for questions. So let's take a minute to reflect and ask our questions. Ooh, some of you have answered this. You can ask your question out loud. You can type it into the chat. You can type it into Pear Deck. Okay, if no one has a question, then why don't you just go? See if you can get it from the amount of kilojoules per reaction, which is for 2 moles of methane and 2 moles of octane. Get that into per gram of methane and per gram of gasoline. I'll give you like a minute to start, ask questions, try to beat me. Yep, you're going to need to use molar masses. If you get an answer, go ahead and type it into Pear Deck. How are we doing? All right, a couple of you beat me there. Okay, questions on this? And also, why do race cars use octane as a fuel? So this would be a good like part F for a free response question. Like if they used this question as your free response, part F might be like, which fuel would you use for a race car? So race cars have to carry their fuel, right? So every gram of fuel they carry is going to slow them down. So with octane, they release more energy per gram. Methanol releases less energy per gram. So with octane, cars can actually carry less fuel for the same amount of energy. And so it would make for a lighter car, which is better for racing, right? It's a negative combustion, or a negative enthalpy, it's going to release heat. And we see here that octane releases more heat per gram than methanol. Okay, that's it. That's our last question for chapter 6. Anyone have topics they want to go over? Or we can kind of go ahead and make one of those little reviews where we like draw the line and come up with the top 4 topics. Either way, we can go either way. I'm for making a review. Okay, sure, let's do that. I'm going to end Pear Deck so that, actually, I don't know if I can end Pear Deck. Hold on. All right, it's going to freak out. So I'm just going to use this page as our review for chapter 6. All right, so take a look at chapter 6. If you had to divide it into 4 topics, 4 of the most testable topics, what would you divide it into? Any suggestions? Okay, yeah, Hess's law is definitely going to be in there. Enthalpy of formation, maybe. But enthalpy of formation is like a variation of Hess's law. So if we had another box, if we had an extra box at the end, yeah, I would do an enthalpy of formation thing. If we don't, you could put it here. What else? Calorimetry. Amen. For sure. What else? So the probably the biggest topic of this whole chapter, you guys don't even think of as a topic of this chapter because it's so like ingrained at this point in time. So energy overall, yeah, you could do that. You could do that as a topic. We spent the majority of the chapter dealing with energy as in one specific form. What was the one specific form of energy this like 75% of this chapter surrounded on? So heat under constant pressure. What would heat under constant pressure be? Heat under constant pressure is called enthalpy. Enthalpy. Yeah, I would certainly put enthalpy as its own category. Okay, so endothermic, exothermic. We started talking about those when we started talking about the signs. So you could have a category under here of like signs of E, W, and Q, and endothermic, exothermic could go there. Or you could put endothermic, exothermic here. I think they would fit either way. What about equations? What kind of equation should go in each box? Yeah, changes in energy. So E equals Q plus W. Sure. Calorimetry should have the lab equation. Yep. So Q equals MC delta T. Or you could have the other version, C equals Q over M delta T. They're the same equation, just rearranged. What other equations? Hess's law has an equation. What's the Hess's law equation? Yep. Work has an equation. You could also throw in like energy equals QP over here. I mean, that's more of a concept than an equation, but it could count. What else do we have? I think that might be all the really major equations. Okay, details inside of these, or like specific problems that come up all the time. Okay, heat capacity. Where would heat capacity go? Any ideas? I would put heat capacity in calorimetry because it's in that equation. For calorimetry, you should be able to deal with the 5 types of problems. So like hot water, cold water, hot metal, cold water, food. Oh, enthalpy of a salt and enthalpy of neutralization. Hess's law, I would say like rearranging reactions. Would be a big one. A big type of question for that. What other details? Oh, you do have like the law of thermodynamics. There's a whole bunch of concepts in here like system versus surroundings. Enthalpy, I would say like, or Hess's law, I would say like energy diagrams. Kinetic energy, potential energy, although that's not really a big topic for us. That would be like a super minute random detail if they throw in like the kinetic energy formula or the potential energy formula. But they might talk about like potential energy diagrams, the potential energy stored in a chemical bond. That would be like an energy diagram. Oh yeah, state properties or state function. Yep. Oh, maybe like enthalpy units. Like, is it kilogram or kilojoule? I mean, is it kilojoule per mole? Is it kilojoule per gram? Units that way. Calorimetry, you could also deal with like air in lab. That's a pretty good list. And can anybody else think of topics that we should sort? Oh, there is another equation. The enthalpy equals energy plus PV. I would say that's a pretty good list. Okay, so now that we see the list, any questions off of that? Or topics you want to talk about? Or problems? So the test will be like a 45-minute type of test. It'll be like 20 multiple choice questions and a free response, something like that. I need to look at the week at a glance. I don't have it pulled up, but I think it's going to be an in-class test. And then I'll have a video on chapter 17 for you for your asynchronous time. Oh, never filled in the work formula. Okay. Good work, you guys. Okay, let me know over the weekend if you guys have questions. You can email them to me. You can put them in the forum. If you guys have questions over the weekend, we can do office hours before class on Monday. Just let me know. Okay, happy weekend. Callie, probably email? Unless you want someone else to answer your questions like faster than I do, because I probably won't check either over the weekend. I'll check a Monday morning, but if it's a question maybe another student could answer, put it in the forum, or maybe you could do both.
Okay, thanks.
Yeah.